Yeah, welcome to today's class. Today we want to look at two-dimensional arrays. We are doing data structure and algorithm, and we started with arrays. So we've done one-dimensional array, and now I want to show you two-dimensional array and a brief intro into multi-dimensional arrays, right? So data in one-dimensional array, we saw data stored in what? In straight line, like 20, 30, 40, 50, like this, right? So this is a one-dimensional array. But sometimes data are represented in rows and what? Columns, right? Something like this, like your spreadsheet, right? These are columns, then rows like this. So example of this is what? Scores of students in different subjects. Um, Differences or sales of different branches of a company, or even a chessboard. When you look at a chessboard, right? So your spreadsheet, that is Microsoft Excel, your spreadsheet, that is two-dimensional array. So what is a two-dimensional array? A two-dimensional array is an array whose elements are themselves one-dimensional arrays. That is, the element of two-dimensional arrays are one-dimensional arrays. So how do you write, how do you represent that? How do you write the syntax for a two-dimensional array? Say, if we say int, let's say max, right? And then we have this, and we'll put this in it, and then we have this. So this is how you declare a two-dimensional array. So this one is representing rows, while this is representing columns, right? So if you ask me how many elements will be inside this array, that will be what? 2 times 3 equals to what? 6. Now, we are having 2 rows and then 3 columns. So 2 rows, 3 columns. So this is column 0, column 1, column 2, 1, 2, 3. This is row 0 and then row 1. So 1, 2. So how many, what will be the value, which is what? 6. So this is 1, this is 2, this is 3, this is 4, this is 5, and then this is 6. That is it. So you can see something here, multiplication. So if I say 3 times 4 equals to what? 12. That means 3 rows, 4 columns. And then we have 12 elements inside. That is what it is. So this is row representation, and then this is column representation. Now, so it means we are going to use 2 indices, which is what? I and what? And J. So for the rows, we represent this with I. For the columns, we represent it with what? With J. Now, how are you going to initialize these two-dimensional arrays? So we say something like this. Int max, right? And then we say 2 and then 3. So this, we have this. Now, inside it, we have 2 columns. So we are going to have something like this, 10, 20, 30, comma, because I told you that the element of a two-dimensional array are themselves one-dimensional array. Do you understand? So in multidimensional arrays, it means that for a 3D array, which is three-dimensional array, the element of a 3D array is an array in which the elements are two-dimensional arrays. So it means if I'm having n dimensional array, right, the element will be what? N minus 1 dimension, right? So if I have a 2D array, the element will be what? A 1D array. If I have 3D array, the element will be what? 2D arrays. So that is multidimensional arrays. So then I will have 40, 50, 60, right? Then I will close this. So this is how you initialize a two-dimensional array. So you can see 2 rows, this row, and then 3 columns, this. So you can see it in form of a table. 10, 20, 30, 40, 50, 60. So this is like matrix in mathematics, right? So this is two-dimensional arrays. How you declare and initialize two-dimensional arrays. Now, how will you store these 2D arrays in the memory, right? Even though you are having it as rows and columns, C will still store, C programming language or the compiler will still store this in a straight line like this. So meaning it will be 10, 20, 30, 40, 50, and then 60. So how are you going to calculate the memory address for this, for this, for this, for this, for this, and for this? Because you're having it as rows and columns at the logical layer. But in the physical layer, it is still stored in the memory in contiguous memory location. So how are you going to calculate the memory address? Now, in the last class for one-dimensional array, I gave you a formula. Same concept will apply here. Now, assuming I'm looking for this 50, I want to find this 50 in the memory. So how is the compiler going to store it? Inside the memory. So there's the formula. So the question you ask yourself is, how many elements will I meet before getting to what? To this 50. That'll be what? 1, 2, 3, 4. So I'm going to skip 4 elements before getting to 50. So I am skipping a complete row, right? So the formula in which the compiler will use to convert the index to what? To the memory address in order for you to locate the element of an array is what? First, let's have something like this. Let's say I have this. So this is 10, this is 20, this is 30, this is 40, 50, 60, right? And then I'm going to have 0, 1, 2, 3, 4, 5. So 1, 2, 3, 4, 5, 6. So starting from index 0. Now let's assume the memory address of this 10 is what? 100. We are assuming. Now, if it is an integer, which is what it is, that is 4 bytes, right? That is 4 bytes. So this 10 will occupy 4 bytes. Then this 20 will start from what? 104. This one will be what? 100 to what? 103. For what? For 10. Right? Now, since it is a two-dimensional array, what would be the formula to calculate the addresses of the elements? Now, let's find this 50. Let's say we have this. Right? So we're having 10, 20, 30, 40, 50, and then 60. So this is row 0, and this is row 1. And this is column 0, column 1, column 2. So this is I, and this is what? J. Now, to derive the formula, assuming we are looking for this 50, now how many elements are we going to skip before getting to 50? 1, 2, 3, 4. So we have passed this. Now, to locate this, that will be what? Let's say max 1, column 1. So we have to calculate this. Now, I is what? I is 1 and j is 1. So if you look at this is 1, right? So we are going this line. Then j is what? 1. So we are coming this line. So where they meet, that is 50. So this one will give us what? 50. That's what it's going to return. Now, how do we calculate the formula? We know the index and we know the value that we are looking for. So how do we locate the address where we are going to retrieve that value, right? So the formula will be I multiplied by what? Columns, right? Plus j multiplied by what? Size of integer. That is size of data type. So data type is 4 bytes. Size of data type, right? Then plus, let's write the formula proper. It will be what? Memory address equals to base address plus then the row, which is I, the index for the row, multiplied by columns, right? Plus the index for the column, right? Then multiply by what? Size of data type. This is what the formula will be. So this is it. Now, how many columns, if we are asked to find 1, 1, so the rows is what? 1. I is 1. Multiply by columns. So how many columns have we? 1, 2, 3. So we are going to pass the complete 3 columns, right? So multiply by 3 plus, when you get to this first column, because what you are looking for is what? 1 and 1. So we are in row 1. When we get to this row, how many columns are we going to pass before we get to this 50? Because we are looking for 50. So we are going to pass 1, just 1. So I is 1. J is 1, I mean. But the total number of columns that we have is what? 1, 2, 3. That's why we are having these 3. So 1 times 3. 1 times 3 plus 1. That is 3 plus 1 equals to what? 4. That is the number of elements you are going to pass, which is 1, 2, 3, 4, before we get to 50. But what is the size of each element? 4 bytes. So that is why we are doing this multiply by what? Multiply by 4. So times 4. That is what? 16. Right? This plus this, that is 16. Now the base address is 100. So that will be what? 100 plus 16. And that will give us 116. Now, if we check, if this one is occupying 100 to 103, this is 104 to 107, this will be 108 to 111. So this will be what? 112 to 115. So this will be what? 116 to 119. And then this one will be what? 120. So the starting address for 50 is what? 116. So this is the formula to calculate the address of any element, right? That is how you calculate the address of any element for a two-dimensional array. So in the next class, I'm going to teach you how to traverse elements in a two-dimensional array and print them out on the screen, just like this. You're going to print this out. So that's what I'll teach you in the next class. So if you have come with me this far, don't forget to give me a thumbs up. So till we see in the next class. Bye-bye.